welcome you back to another episode of our series on further mathematics for SS1. So yeah, we're going to be dealing with sequences and series. So what do we mean by sequences and series? Sequences and series has to do with that part of mathematics that is talk about the progression of numbers. So that's where we'll talk about arithmetic progression and geometric progressions. So basically let's dive into the concept today. So there are some things we are expected to cover today. So the first thing we're supposed to cover is defining sequence. We need to be able to understand what sequences are. So also we need to understand the how to find the end stem of a sequence, series, and so on and so forth. Also the infinite stem of a sequence and all the rest of concepts like that. So let's begin this class. So first of all, let's talk about sequences. So sequences, what is a sequence? A sequence is basically a progression of numbers, as I mentioned earlier. So we have a progression of numbers, and these numbers their progression is governed by a particular property. So they have a particular reason their manner of progression. So for example, in this number A, we have this sequence as 5. We start as at 5, then we go to 9, then we go to 13, we go to 17, we go to 21, as you can see on the screen right now. So you can see that we are increasing progressively. We are increasing the numbers progressively from one to another. So by what value are we increasing them progressively? We don't know yet, right? So but basically, I can tell you that from 5 to now it takes a jump of four numbers, then an increment of 4. Then from 9 to 13 takes an increment of 4. Then from 13 to 17, the fourth number takes another increment of 4. So you can see that the common difference here is 4, 4, 4. Now that concept of common difference is also exploited in this concept of sequences and series. Then let's go to the number E. We have 32, 16, 8, 4, and 2. So for you to go from 32 to 16, you have to divide 32 by 2. For you to go from 16 to 8, you have to divide 16 by 2. For you to go from 8 to 4, you have to divide 8 by 4, and so on and so forth. So it is this regularity, this resonance of this kind of numbers, this set of numbers that makes us call them a sequence. So it's a sequence that is often predictable. It's often predictable in mathematics. So but in nature we have different sequences in naturally nature that cannot be predicted. But for example, you have seen a regular flower with five petals. So basically all kinds of that flower will definitely have 5 petals. So that's kind of what I call a series. Like it is predictable, it is regular, it is kind of periodic, it's kind of like a wave in physics. So we'll talk about waves in physics in a particular video in this course. You can check that video in the physics playlist of this channel. So let's move on to something else. So there are different patterns in series. We have each term, the first term is generated by subtracting 5 from the term immediately. So there is always a particular rule behind it, deriving each term of a series. That is basically what I'm trying to make you understand. So let's move on to another concept in this video. Let's talk about linear sequence. So a linear sequence is basically a kind of sequence that is an arithmetic progression. We also call it an arithmetic progression. In a linear sequence, the difference between a term and a term immediately preceding it is always a constant. So basically, the difference between a term and a term before it is a constant. So when you subtract a term from a term before it will give you a particular constant, and it will definitely be common. So that constant number is called the common difference, and it is designated by letter D. That is basically the concept we are trying to do here. Just subtract. You are trying to look at what is the value of the steps by which you are forming this sequence. So that is basically the drive for this kind of mathematical concept. So let's move on to something else. We have the concept of the end stem of a linear sequence. So the end stem of a linear sequence is basically the particular term of that sequence. For example, the first term of a particular sequence is at the first position of the sequence, the second term is at the second position, third term is at the third position, the fourth at the fourth position, and so on and so forth. So for example, we often denote that as A. The first term is often denoted as A. So in this equation, you can see that we have T1 equals to A, then T2 minus T1 equals to D. That is the common difference. That is the steps for each of the sequence. So when you progress, you can say T2 equals to T1 plus D, and that is equals to A plus D. So moving on, T3 minus T2 is equals to D at the same time, because that's the common difference. So also T3 minus T3 equals T2 plus D, that's A plus D plus D. That's A plus 2D, because T2 is equals to A plus D. So T2 plus D is A plus D plus D. That's A plus 2D. So if you move on, you will continue seeing that in general, Tn is equals to a plus n minus 1 d. So basically that is the general form of the nth term of a linear sequence. The nth term is equals to the sum of the first term and 1 minus the product of 1 minus the product of 1 minus the number, the term number, and the common difference. That's a plus n minus 1 d. So that is the concept we are dealing with, and that is the basis for the formation of arithmetic sequences. So let's move on to an example which will illustrate this concept. So in this example, we're asked to find the 40th term of a linear sequence. So let's begin to deal with that. So I have to deal with the nth term of a linear sequence. So let's deal with that. The nth term of a linear sequence is basically denoted by the term of the sequence that we have at a particular number. So that is the order of it. When you arrange the terms in order of their occurrence, what value does it have in that sequence? So we are going to be dealing with this question in this on the screen now. So let's deal with it now. So we have find the 40th term of a linear sequence 6, 11, 16, and 21. So in this case, we have a sequence here. We're asked to find the nth term of the sequence. So the first thing we are going to do here is that we are going to look at the sequence. So we have 6, 11, 16, 21. 6, 11, 16, and 21, right? Now in this sequence, we have the first term is 6. Let's denote it as T1 equals to A. Then we'll use that to calculate other things. Then we also have the common difference. So for my earlier definition, I said the common difference is gotten from the difference. The common difference is the difference between a term and the term before it, right? So that means let's speak into terms. For example, the second and first. So the common difference is equals the positive difference between the second and the first. Or rather the difference. Just say the difference. So that's the second. Subtract the first from the second. That's the common difference equals 11 minus 6. That will be 4. So the common difference can be negative or positive. But if it is negative, just know that the arithmetic progression is decreasing in value. Or if it is positive, know that it is increasing in value. So now let's move on to that. We have the first term, which is 6, and then the common difference is 4. So now we are looking for the 40th term. So in general, Tn equals to a plus n minus 1 times d. So in this case, we have our Tn as 40. So the 40th term is equals to a plus n minus 1d. So that's T40 equals to a, which is 6 plus n minus 1. What is n? N is 40. 40 minus 1 times d is 4, which is the common difference. So when we continue with that calculation, we have T40 equals to 6 plus 40 minus 1, that's 39 times 4. And by my knowledge of mathematics, that will be 6 times plus 39 times 4, which will be 156. That's 6 plus 156. That will be equals to 162. That will be our answer. You can cross-check the answers over your end and verify that they are correct. So that is the concept we are trying to introduce to you guys today, and I hope you understand that. So that is 162. So I guess you can 4160. Yes, that's the concept. That is it. That should be the 40th term of that sequence. So now let's move on to the common difference is actually 5 instead. It's actually 5 instead. So the common difference is 5. 11 minus 6. That will be 5. So our common difference is 5. I just checked the correction now. It's actually 5. So instead of 4, we use 5. That's 39 times 5. That will be 195. And then at the end of the day, we'll have 201. The final answer. So we have 201 as the final answer. And according to my book here, it is actually the correct answer. So that's the question and that's the solution. I hope you understand that you can even cross check it and see and verify. You can verify whether it's correct on your end. So let's move on to another concept in this video. We have another example which you can solve on your own. So this example, we have it as the first term of an arithmetic progression 15th is 15 and the ninth term is 35. Find the 15th term. So basically, you can try this question and you can just look at the solution, look at the progression of how it is solved, and let me know what you think about it. So that's the example you are going to be trying in this video. Let's move on to something else. We have another concept which we'll be talking about, which is the arithmetic mean. So the arithmetic mean, how do you calculate the arithmetic mean? So many of you have come across the arithmetic mean, but you don't know the basis of how it was formed. So this is the basis. The arithmetic mean of two numbers, p and r, is a number q between p and r, such as p, q and r are in an arithmetic progression. So that means three numbers in our arithmetic progression. The number between those three numbers is the arithmetic mean. So for example, that means our difference will be q minus p, and it will also be equal to r minus q, because that is a common difference. So at the end of the day, q minus p equals r minus q, and then 2q equals p plus r. And then when we make q the subject, p plus q will be equals to p plus r all over 2. That is the concept of arithmetic mean. So let's go to exponential sequence. So when I talk about exponential sequence is a sequence that the ratio of a term and the immediately preceding it is always a constant. So basically, the ratio of the term and the term immediately preceding it is always a constant in a exponential sequence. So in an arithmetic sequence, we're talking about the difference, but in an exponential sequence, we talk about the ratio. The ratio must always be a constant. So that is one property of it. So that means in this case you are dividing, you are not subtracting, you are dividing. So let's talk about the nth term of an exponential sequence. So the nth term of an exponential sequence is let the first term of an exponential sequence be a and the common ratio be r. So if tn is the nth term of the sequence, then t1 equals a, and let's move on to this one. So that's so that means t2 over t1 equals r. So that's the common difference, the common ratio rather. So in this case, we're dealing with ratio, not difference, right? So then t2 is equal to tr, so 1 times r, that's ar. So t3 equals to t2 times r, that's ar squared. Then we also have so on and so on and so forth. So in general, the nth term of a sequence is equal to a multiplied by r raised to the power of 1 minus the 1 subtracted from that n. So that's tn equals to ar raised to the power n minus 1. So that is the general formula for nth term of an exponential sequence. Now this is often quite tricky, and I need you to listen carefully, because the exponential sequence, it has some quirks to how it's solved. So next, let's move to the geometric mean. So we've talked about the arithmetic mean some minutes ago. So let's talk about the geometric mean. So for the geometric mean, we have geometric mean for let's see this example. So suppose x, y, and z are consecutive terms of geometric progression. Then the common ratio r can be written as r equals y over x, right? So or r equals z over y, right? So then y over x equals z over y, because this is a ratio. So and that is the common ratio. So when we equate it, we have y squared equals xz, and then at the end of the y equals xz, the square root of xz. So that is how you calculate the geometric mean. Those of you who have done some classes in economics, you would have understood this concept. I also have the harmonic mean, but we are not going to talk about harmonic mean today. Let's talk about the that was the 11th concept. Then let's talk about the 12th concept, which is series. So series, yes, series. Series is basically a progression of a sequence. So for example, a series is a partial sum of sequence. So if t1, t2, t3, t4 are terms of a sequence, then the sum is equal to t1 plus t2 plus t3 plus t4. So in series, whatever series, that's what I'm talking about, the sum to infinity, sum to n, and so on and so forth. So these are concepts we'll be talking about in the series, and I hope you grasp those concepts. So let's talk about something else. Something else to talk about in this course, in this topic. So this topic is something that is quite it's a wide topic, and you actually deal with it in other higher educational studies. So let's talk about the sum of n terms. So the sum of n terms. So let the first term of a linear sequence be a and the common difference be d. So we wish to find an expression for the sum of n terms of a linear sequence. So let the sum of the s subscript n. So that means Sn equals a plus a plus d plus a plus 2d plus so on and so forth till we get to the Tn. So and at the same time Sn equals to Tn plus Tn minus d plus Tn minus 2d plus Tn minus and so on and so forth till we get to A. So at the end of the day, when we add them together, 2Sn equals a plus Tn plus a plus Tn plus a plus Tn, and we keep adding a plus Tn so on and so forth. So at the end of the day, we say 2s equals to n multiplied by a plus Tn, because we have n times of a plus Tn, so we have it repeated in n places. So at this point in time, we have Sn, that is sum to n, equals to n over 2 times a plus Tn. So when we evaluate that, at the end of the day, we'll have the sum to n equals that expression, n over 2 open bracket 2a plus n minus 1d. So this concept of series is something I've talked about in the previous episode on this course, and I hope you understand this concept. So this is where we'll actually be stopping this course. Yeah, we're stopping here because of the of the length of this video. So I hope you understood this concept, and let's move on to the summary of this video. So this summary, we'll talk about the concept of things, and this is the summary of what we've talked about in this video. You can check them out and revise them to see if there's anyone you still don't understand. You can let me know in the comment section of this video. Thanks for watching, and I hope to see you in the next episode.